Okay, back at the notes. I'm going to go to week 10 or section 10 of the notes. And again, I want to point out again, this is these red links are linkable. In other words, click on them, it'll bring you right there. So in week 10, materials covered, exponential and logarithmic functions, exact and approximate, solving exponential equations, solving logarithmic equations, yada, yada, yada. So what I'm going to do is I'm going to go to the related sage code. All right. Now, I want to point out there's two sections of related sage code. All right. So there's 10.6. I'm going to click on that. And I just want to, quickly go through this with you. And again, I'm using a software product, a Sage that's installed on my computer. But again, I think in the last lecture we talked about, at least the last Sage instance, we talked about what happens when Sage goes down on the web, and it does. I mean, sometimes no one's willing to serve a Sage account to you, and if that's the case, you can't get your computations done on the web. You have to wait for someone to come along willing to allow you to do a computation, and that could take hours. That could take hours. So I have it installed on my computer. I'm going to type this in, code I'm seeing. Just return. Now, if you're on the web, it's shift return. X is a variable. I mean, we've done this, a god awful number of times. And I got to say that you should learn to type. I'm getting a little tired, right? So solve. Go through this. I want to point out that it solved it for me. And I want to go through some, certainly, if you can't just, man, this is going to be horribly confusing for you. So I want to just go back over the notes, and I want to look for that problem where I get an equation, e to the x minus 6, e to the minus x, right? It's right here, right? Now, you were expected at some point, I'm not saying maybe not now, but you're expected just by hand. And it says, approximate to 4 decimal places, all right? So I'm going to say I did that, and I got an answer by hand, and you should be able to do it by hand. What I noticed over here, though, is that it actually writes down an exact answer. And of course, if you were to solve that equation, you'd also write an exact answer. The exact answer you'd write down, no, is not log, because you think log is log base 10. In the real world of mathematics, though, log stands for log base e. That's in the real world, all right? Now, at this level, log to you probably means log base 10. Now, they also give me what's known as a complex solution to the problem. I would not worry about that. But what I want to do is I want to find out what is log base e of the number 3. So I'm going to force, at least I'm going to try to force Sage to do the computation for me. And what does it give me? 1.0986, yada, yada, yada. Well, they want 4 places. And I got 4 places over here for you. All right, let me go back to the code. And I want to put this one down over here. I'm going to copy paste. And again, we're not trying to confuse you with this. We're trying to promote this as a way to transition to upper level courses. All right, so this one also over here gives me an answer, and I want to just scroll back over it and see if I can see that problem, and that's 5 to the x. All right, let me scroll back. It's right here. All right, let me see if that's the right one. 5 to the x minus 5 to the minus x, divide by 5 to the x plus 5 to the minus x equals 2/3. Yeah, and what I want to point out, I do see the answer that they say is over here. X equals a half. I'm seeing that clearly. Again, at some point when you're starting to do work, you should also be able to show that's 1/2. But they give another answer. And the answer they give me, which might confuse the hell out of you, is actually complex. All right? I'm going to copy. And I'm going to paste. And I want to show you that's complex. So dot n, and see if that works. And what do I get? You know what? It's not doing it. So I have to go back over here, and I got to tell you why it's not doing it. It's looking at the log, minus square root of 5, and it's just not doing it. I'm going to see if I can do that and approximate it. So I'm going to type in the code again. I type this in over here. I'm going to copy paste. I'm trying to force it to do a computation. And that's going to be 5, right? I'm going to put down 5.0. But when I put a decimal into Sage, it's kind of forcing it. And now I see the I. So what I'm going to do is I'm going to type in the rest of it. Let me do that for you. I'm just doing copy paste. And I think most people know how to copy paste, right? Let's see what happens. Notice it didn't do the log 5. Let me go back and force it. You should be concerned about that and say, why doesn't it do that? It knows that log base e of 5 is not an exact number. It's not, you can approximate, but can't write the exact form of it down. So just don't do the computation. Let's do it now. And what do you get? The complex form, which is 1/2 plus some number times I. All right. All right. Well, I'm going to go back. I'll go back to the notes. And we just finished this portion. All right. I'm going to scroll back to section 10 now. Give me 1 second to do so in the index. We try to organize things for you. Hope it's organized enough for you that you can follow it. So we just did this related stage code. Now I want to do this related stage code. All right. Let me clear. I'm going to reset again. Oh, 2 variables, x, comma, y equals var, x and y. Oops, I'm defining x and y as variables. And we'll try to copy paste. And this is what's known as a simultaneous equation. A system of simultaneous equation is, one equation linear, other equation linear. You did a math 100. What's it going to return to me? The values of x and y that make it true. And that's pretty nice. Right? That's really nice to know. So I'm going to say over here, this is kind of like an introduction to linear algebra. And we've done problems like this. And someone says, what problem is that? It looks like this problem over here. How do we do that? We solved by the addition method. And we did it by hand. And you need to learn to do that by hand. That's something you learn Math 100. What do we say the answer is? X is -3 and y is 4. And I clearly see that over here. All right. Pretty simple. This is a model, right? You can type in other equations, including more difficult ones, including nonlinear ones, using this format over here. You learn by looking at other people's code, right? What are you looking at? You're looking at my code, and you can extend my code to solve bigger and more difficult problems. I don't think I'd want to code this problem over here because it's really simple to do by hand. But the bottom line is you need to start to learn how to code simple problems. So when you get to more advanced problems, you can actually code those on a machine. And machines are really important in the STEM related career areas. All right, that's science, technology, engineering, and mathematics. All right, thank you.